Hi, I'm Richard Stillman. I'm with Doane University. This is my General Chemistry 2, Section 1, Advanced Concept Presentation on Ferromagnetic Fluid. So typically I do an experiment and go through all of that with you and show how it's actually happening. This time I'm focused more on what's going on in it. I wasn't able to get the printer ink toner needed to do the assignment due to a family emergency. Um, because of that, I'm going to go into a little bit greater detail as to what's going on, and I recommend that you check out a video on this actual happening. But what it does is, so ferrofluid consists of many nanometer sized particles. These nanometer sized particles are suspended in a solution, so it's in a liquid state. These nanoparticles are made of magnetite, um, and this magnetite is a magnetic. It's a rare earth metal, and what it does is, because these are nano-sized particles, they can exist in a colloidal suspension. So basically, they can be dispersed, and there's surfactant that covers the iron oxide that these magnetite particles secrete. There's surfactant that covers that and keeps the other particles from sticking to each other. So until introduced to a magnetic state, the magnetic state, or like a magnet. So it's basically getting magnetized because it's exposed to a magnet. This magnetite changes its property, and this is because it's super paramagnetic. And what that means is that it can exist in a liquid state, it can exist, not act like a magnet at all until it is introduced to the magnetic field. So that's like paramagnetic. This is super paramagnetic. So you can tell it's a very um, it's a very quick reaction. It can go from a liquid to almost a solid. And when it's in its like solid state, it basically mimics the edges of the magnetic field because of the amount of force in the magnet itself. So it's a pretty cool little experiment to watch. I watched many to try to make this video and learn. A couple interesting notes. First ferrofluids were developed by NASA. They ended up leading it to be able to take liquids into space through that technology, and it's been used in other stuff like rotary engines, MRIs, the contrast that goes into the IVs is a ferrofluid. So that kind of wraps up this presentation. Hopefully I've explained enough for y'all to get the picture. I'm going to basically all right, had a little technical difficulty there. I just wanted to wrap this up saying ferrofluids, they're on the nanoscale. The nanoscale is basically I think it's 1/1000th of a meter. So it's a very, very, very small size. And when you look at that at a macro scale, ferromagnetic materials like refrigerator magnets, they have that permanent function, or they have, they're, I guess, permanent function, as opposed to the temporary that you would see in a super paramagnetic experiment. All right, that kind of wraps it up for this week. Once again, apologies that I wasn't able to make it a little bit more cool and entertaining. Um, but you know, life happens. So, all right, thank you for listening. Have a good week.